Dear Dr. Wu, this is Fan Jin, and here's my presentation for the network science and applications. My topic is the deployment of smoke sensor for maximizing detection probability. There are 4 parts in my presentation as required. There are several programs in my project. They are mainly to solve 2 problems accordingly. And the first problem is the deployment of the smoke sensor nodes for maximized detection probability. To be specific, in this project, is it to use a minimum number of smoke sensors to cover the 95% of the monitoring area based on my deployment strategy. The second problem is the localization for these sensor nodes. For the problem 1, the deployment, actually it varies in different scenarios, and it is constrained by several elements. Thus, before I introduce my strategy, there are several assumptions to be listed. First is the sensor used in the network are 100% reliable. And the second is the sensors used in the network have effective sensing radius of R, which also means that it has a detecting size of a circle. The fourth is the monitoring area in my network is a square, and all the parameters and their values will be listed here and in my demo. Okay, for the problem 1, there are several strategies for deployment, and in my project I use a square grid strategy. It is a sensor field. The sensor field is represented as grids in this strategy, with the sensors placed at the grid points. Target can be located easily at any time. From the left figure, we could see there are several types of grid strategy, like triangles, squares, and hexagon. And as assumption listed before, the whole monitoring area is square. Thus, I'm use a square grid strategy for better performance. Another key for better performance is to eliminate the coverage holes near the boundary of sensing area and the obstacles. You can see the right figure. In this step, offsets between counterpoints and the boundary are reserved to allow more sensors to be deployed in the next phase. With the proper selection of the offsets, we can earn more coverage contributed by counterpoints. The calculation of the offset, is the R divided by square root of 2, and the distance between every 2 adjacent counterpoint is 2R divided by square root 2. And for the problem 2, the localization, the algorithm used in my project is MDS map. The principle of the multidimensional scaling is to convert distance into an inner product matrix. The inner product matrix in given vectors shall be the unknown coordinates. MDS map could compute the shortest path between all its computes, the shortest path between all pairs of nodes in order to approximate the missing entries of the distance matrix. And the table here also lists several parameters, and their values will be used in the problem 2. Also, you can see the whole monitoring network is a square with a size of 8 by 8, and the communication radius of the sensor is 5 meters. reference nodes of this number is 4, and this number of unknown nodes is 10, 50, and 100. In my demo, I will show the 50 and 100. So iterative times is 50. Here is the simulation result for problem 1. It is deployed by the grid strategy deployment. All the details will be shown in my demo later. To be compared, I also make another program for a random deployment strategy. You can see to contrast, you can see the performance. Here is the simulation result for problem 2 with the number of 10, 50, and 100. And you can see these are they are highly matched. The accuracy, the performance is good. For the conclusion, for the deployment, the square grid strategy could acquire good performance. It could get higher coverage rate as small number of smoke sensors as it could. However, there's still a lot of progress could be made, as a grid coverage strategy is a simple algorithm, and there's still a lot of detection area are overlapped. Besides, the deployment is fixed and not that dynamic, and it could not be automatically fit to every environment. For the localization, the MDS map algorithm can get coordinates of the unknown sensor node. Based on the simulation, the program could give a localization of the sensor nodes accurately. The localization coordinates and the coordinates of the unknown nodes could highly match. Okay, then here's my demo part. Here I run the program for the problem 1. You can with the square grid strategy, it just use 49 sensor nodes to cover more than 99% of the whole area, and the performance is quite good. And if I to compare, I run the strategy with the deployment with random strategy, random deployment. You can see it is slow because it need to match the threshold of 95% of the coverage. You can see it almost need 136 sensor node to cover the more than the 95% of the area. Okay, and now this is a program for the problem 2, and I run it. Oh, here is the unknown node, the sensor nodes, the unknown sensor nodes is 100, and actually the red the the nodes in red are the unknown nodes, and the black in the four corner are the reference nodes, and the blue circles are the marks. Okay, I can then change the number to 50 and run it again. You can see it is highly matched. Okay, my demo part is over, and thank you.